Student, I am H.G.TIWARY of DMCCL Greedy. I am going to give concept of adjoint and inverse matrix. How we can find adjoint and inverse of a square matrix. Student, you should know only a square matrix has its inverse and adjoint. So no rectangular matrix has its adjoint inverse. So what is adjoint of a matrix? How we can find adjoint of a matrix? I am going to show example before you by which you can understand. So A is a matrix student of order 3, a square matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. It is a matrix or a square matrix of order 3. It is a square matrix order 3. To find adjoint of this, first of all, we find cofactors of all the elements. That is cofactor of A11, that is C11, cofactor of A12, C12, cofactor of A13, C13. So in this manner we find C21, C22, C23, C31, C32, C33. These are the cofactors of corresponding elements of matrix A. You know how to find cofactor. I have discussed in determinant chapter to find cofactor in minus. Cofactors are also denoted as C11, may be denoted as A11 in some books, C12, A12, C13, A13, so on. So this symbol is also given in other books. So we find a matrix B. Find matrix B of taking cofactors of this. These elements will be replaced by their cofactor. So we are getting a matrix B of this C11, C12, C13, C21, C22, C23, C31, C32, C33. It is a matrix B made by cofactors of corresponding elements of A. We made a matrix B by taking cofactors of corresponding elements of A. So adjoint of matrix A, also in brief we can write A ADJ of A is transpose of B. B का transpose. We take transpose of B. Therefore, now adjoint of A is equal to, here first row converted into first column, second row converted into second column, third row converted into third column. This is the adjoint of matrix A. This is the process to find adjoint of this matrix A. Student, I am taking example before you. Let A is a matrix 1, 2, 3, 4, 5, 2, 2, 2, 1 of order 3. It is a matrix. Find adjoint A. So first of all we find cofactors of this element. Cofactor of 1. that is cofactor of 1 is equal to, we delete this row and this column, so it is this row and this column 5 2 2 1, so that is 5 minus 4 1, this value is 1, that is C1 1, that is C1 1 is 1. Next we proceed to find C1 2, C1 2, we proceed to find C1 2, C1 2, so C1 2 any cofactor of 2, C1 2, that is, here is a 2 plus 1, that is odd, so minus, now this row cancel this column, 4 2 2 1, 4 2 2 1, so minus 4 minus 4, it is 0. C1 3 student, C1 3 cofactor of 3, this row cancel this cancel, 4 2 5 2, so here is a even, so positive sign, so 8 minus 10 minus 2. Now C2 1 is student, C2 1 cofactor of 4, this row cancel, this column cancel, 2 2 3 1, 2 2, here is a minus 2 2 2 2, C2 1, this cancel 2 2 3 1, so minus 2 minus 6 minus minus 4, it is 4, C2 1, C2 2, C2 2 we take C2 2 of this 5, so it will be this row cancel, this column cancel, 1 2 3 1, 1 2 3 1, here is even, so positive sign, 1 minus 6 minus 5, so next C2 3 minus, here C2 3, this cancel this row, this column, 1 2 2 2, 1 2 2 2, so minus 2 minus 4, so minus minus 2, that is 2, and C2 1, C2 3, C3 1 is student, C3 1, this row cancel this column, 2 5 3 2, 2 5 2 5 3 2, see this row cancel this column, 2 5 3 2, so 4 minus 15 minus 11, so C3 2 is student minus, and this row cancel, this column cancel, 1 4 3 2, 1 4 3 2, so minus 2 minus 12 minus 10, so 10, C3 2, C3 3 student, C3 3 cofactor of this row cancel this, 1 4 1 4 1 4 2 5, so that is 5 minus 8 minus 3. So we have got all the cofactors of this matrix A. So we directly taking adjoint, we can find directly adjoint of matrix. Adjoint of this matrix, adjoint of A will be, here we will take that is C1 1, C1 1, C1 2, C1 3, C3 1, C3 2, C3 3, and C1 1, C1 2, C2 1, C2, C2 1, C2 2, C2 3, and C3 1, C3 2, C3 3. Now substitute the value we can find directly C11 is 1, C12 is 0, C13 minus 2, C21 4, C22 minus 5, C23, 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 C232 and C31 minus 11, C32 10 and C33 minus 3. So this is the adjoint of A. This is the way to find adjoint of a matrix. We find cofactors respectively, then this cofactor will be calculated according to the row, and then we find adjoint. We will convert this in the first row, first column, cofactor, second row, second column, third row, third column. So in this way, we find adjoint of a matrix. Now student, there is a property. If A is a square matrix, if A is a square matrix of order n, then adjoint A into A and A into adjoint A is equal to determinant A into unity matrix of order n. So A is a square matrix of order n, so a determinant A multiplied with unity matrix of order n. It is a property, it will be helpful in solving the problem, student. You have to remember this property. Now student, I am coming what is similar matrix and non-similar matrix. What is similar matrix? Similar matrix, singular matrix and non-singular matrix. What is similar matrix, student? Similar matrix. A square matrix of order n is said to be singular if their determinant is equal to 0. If a square matrix of any order n, determinants will be 0, this will be a singular matrix. So, any square matrix of any order is said to be singular if determinant is equal to 0. For non-singular matrix, a square matrix A is said to be non-singular if their determinant is not equal to 0. If any square matrix whose determinant is not equal to 0 is called non-singular. Student, non-singular matrix has its inverse. Only non-singular, student, you keep in mind only non-singular matrix has its inverse. Similar matrix has no inverse, only non-similar. If A is a non-similar matrix, that is determinant is not equal to 0, so A inverse exists. A inverse exists, and A inverse is equal to student adjoint A by determinant A. This is a formula to find A inverse. A inverse is equal to adjoint A matrix by determinant A. If we divide, we can find this A inverse matrix. Now, student, there is some properties of inverse and adjoint matrix. So, properties is that is first one adjoint A into B matrix of adjoint B is equal to adjoint A into adjoint B. This is a property. Adjoint A into B is equal to adjoint A into adjoint B. Second, AB inverse is equal to B inverse into A inverse. It is called reversal law of inverse matrix. Reversal law. Reversal law. This is a reversal law of this second property. Third one property A transpose inverse is equal to A inverse transpose. Student, A transpose inverse is equal to A inverse transpose. Fourth property, student, here determinant of AB is equal to determinant A into determinant B. 5. Student, if A is a square matrix of order n, then determinant of adjoint A is equal to determinant of an minus 1. As note, if A is a square matrix of order 3, then adjoint A is equal to determinant A 3 minus 1, that is determinant A square. In this way we will use this property. It will be helpful in solving the problem of one mass question. Now other property also we will take into consideration, student. Next property is that next property number 6. If A is invertible matrix, if A is invertible matrix, then A inverse is A invertible symmetric matrix, then A inverse is also symmetric. These are the properties, student. Property of 6. Then other property A is a non-singular matrix of order n, then adjoint 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 A is equal to determinant A n minus 2 into A matrix. Adjoint A is equal to determinant A power n minus 2 into A matrix. These are the properties of inverse matrices at adjoint A transpose is equal to adjoint A transpose. Adjoint A transpose is equal to adjoint of A transpose. These are the properties of inverse and adjoint matrix. Now we will take a problem just before you to solve this. I am taking a problem book, first exercise 7, question number 12, find inverse of matrix A 3 minus 5 minus 1 2. It is a 2 by 2 square matrix. So what is the inverse of this? So first of all, we will find determinant of this. If its determinant is not equal to 0, then it will be non-singular and its inverse exists. So solution, first find determinant of A, 3 minus 1 minus 5 2. So 6 minus 5, so 1. So A inverse exists. A inverse exists because determinant is not equal to 0. So for A inverse, we find cofactor of this. That is cofactor C1 1. So this row cancel, this cancel, only 2. 2 is the cofactor of this. This row cancel, this cancel 2. C1 2. Here is the odd 1 plus 2, 3 odd minus. Cofactor of this cancel, this cancel. Minus 1, 1. And then cofactor C2 1 minus. So cofactor of this row cancel, this cancel. Minus 5, 5. It will be 5. So C2 2 student. C2 2 cofactor of this cancel, this cancel. 3. So we have got cofactors. So we find adjoint. First we find adjoint of the matrix. Adjoint of the matrix. Adjoint A is equal to C1 1, C1 2, C2 1, C2 2. Put the value. C1 1 is 2, C1 2 is 1, C2 1 is 5, C2 2 is 3. This is the adjoint. So A inverse is equal to adjoint A by determinant A, adjoint 2 1 5 3. Determinant A is 1. So this is the inverse matrix. It is order 2. I have taken very simple examples before you to clear the concept how to find inverse matrix. So student, I have given concept of adjoint and inverse matrix. Student, only a square matrix had its adjoint inverse, and similar and non-similar matrix. Similar matrix, a square matrix whose determinant is equal to 0 is similar matrix. Non-similar, a square matrix whose determinant is not equal to 0 is non-similar matrix. Only non-similar matrix had its inverse, and properties of inverse and how to find adjoint inverse I have given in this video. In next video, I will come with harder questions. Thank you.